Prudent Scholars in association with Goa Headmasters Association.
A very good day to my viewers and all the students who are studying mathematics in class 10. Rain fills the size of the vessel. And before I explain to you what this entire quote means, let me give you an example. Say for example, you are standing outside where it is pouring and you want to collect the rain. If you are holding a spoon, then you will be able to collect only that much of water. If someone is holding a jug, that person will be able to collect that much of water. And if someone digs a pit and then he is collecting the entire rainwater so that everyone can benefit, he can collect that much of water. So, rain fills the size of the vessel. Okay? Why this quote? Is because a number of times you must have been told, that mathematics is very difficult. Since the time you were in, going to the first standard, probably your parents or your family members must have told, hey, now you have to be very serious, okay? Because you are going to the first standard, maths is there, maths. And there's a little bit of fear that comes in. And as you go higher, and then you realize that teachers start telling you, now it is no more just numbers and addition, now you will learn about some x and y, and the fear continues. And to a point when you have reached in class 10, you are already so much with that pressure that you have closed that vessel. That vessel is nothing but your brain, and you're just holding it that much. Okay, I'm scared. And you will not be able to, study, learn and understand. That's the reason I've put this quote, and I want you to open that mind completely so that you can grasp as much as possible. The wider and the bigger container or the jar that you hold, the more information you'll be able to take in. Always remember that whatever you believe over here is whatever you will be able to do. If you think, I can't solve those word problems, they become so difficult, you'll not be able to solve, because it starts from here. Start thinking that you can do. Take it as a challenge. Don't think of math problems as problems. Take them as challenges. Then only you will be able to solve. The moment you think about a problem, you always feel like burdened up. But when you take something as a challenge, then you are ready to fight. Whenever you go on the ground and you're ready to play, is this a challenge match? The moment you say that, you are already pumped to play better. But if it's just, regular match, then you don't play well. So it starts from here. Start believing that you will be able to do math better and really well, and you will actually be able. That's the reason. Rain fills the size of the vessel. Okay. Before we start with the chapter today, I will show you a pattern. Okay. Just picturize this and try and continue the pattern. Can you think of how would be the next line coming in over here? And probably you must have thought it would be this way. What about continuing it a little bit further? How is your imagination taking you to draw the next line? Is it this way? What about next? And this pattern continues. Now what has happened over here? You have analyzed a little bit of information initially, and you have continued the entire sequence. Isn't it? So, this is nothing but a pattern. I'm always thinking about something. I've already seen what is there in the past, and I'm projecting it further. this is just a figure. Let us take some numbers and see if we can really do it with those numbers as well. 25, 30, 35. And then if I put a blank over here, can you think what would be the next number? 2 seconds to think about it. Some of you all must have thought a number, some of you all must have thought it to be 40, isn't it? If you thought it was 40, then you're right. What about the next number? Are you thinking that it is 50, 45, 35 back again? What are you thinking? 45? Then you're good. What about the next number? 50? And you must have realized by now that there is some kind of a pattern. Keep this thing in mind. Continuing it further, 55, next number, now it is sure that you will always think it is 60 and then 65. Let us take another example. 1, 2, 3 and 5. Now this one is a little bit difficult, but I'm sure you'll be able to fill up this gap. Which number are you thinking of? Are you thinking of 6 or 7 or maybe 8? It is 8. So what is happening here? 1, then 2. 1 and 2, next number is 3. Okay. 3, 5 and next number is 8. I've just tried to give you a hint. Try and see if you can get the next number. 5 and 8, what could be the next number? 13? Cool. What about next? 8, 13 and then 21. 13, 21 and 34. 21 and 34, 55. Now what has happened here? We have seen 3 patterns, and all 3 are different. First one is just a sequence, okay? Second one, when it comes to those numbers, every next number that comes is just an addition of 5. So 25, next number, plus 5 gives you 30, plus 5 gives you 35, plus 5 gives you 40, and so on. When the next example comes, it is the previous 2 numbers added to give you the next number. So 1 plus 2 gives you 3, 2 plus 3 gives you 5, 3 plus 5 gives you 8, 8 plus 13 gives you 21, 13 plus 21 gives you 34, and so on. Okay. Now, this last one, this example, what you have seen is nothing but Fibonacci sequence or Fibonacci progression, Fibonacci numbers. What is it? It is just, Fibonacci is one of a great, I would say, mathematician, you can call him, and he came up with this sequence. And this sequence, if you try to draw it in form of figure, like how would I do it? I'll take a compass, okay, take a 1 centimeter and radius and then draw a figure. Continue with 2, same thing continue with 3, and then you will get a sequence like this. And this sequence is seen throughout anywhere possible in real life. The shell of the snail follows Fibonacci sequence, and I'm sure you'll be a lot surprised, and the first time I heard about it, even I was surprised. The entire galaxy, the spirals of the galaxy follow Fibonacci sequence. Even a plant which is curling again follows Fibonacci. Even the petals of the rose follow this. So, what am I trying to put across to you? There is always a sequence, there is always a pattern. Even your ear also follows Fibonacci sequence. Even your finger, these joints which bend, they also follow Fibonacci sequence. The first bend is at 1, second again, then 2, this is 2, and then 3, and then so on. So that is Fibonacci sequence. Are we studying this in today's class? No, but it's something interesting. You need to just Google it out and learn. It's a very interesting topic of Fibonacci sequence, Fibonacci numbers. Okay, but what we are going to study is the example above that. What has happened? 25, 30, 35 and so on, right? Every next number that we dealt was an increment of plus 5. That is nothing but arithmetic progression. Okay, what are we doing? We are progressing in that sequence by doing what? Just by mere arithmetic addition over here. Okay, so arithmetic progression, nothing but it is a sequence, or you can call it as a projection also, which only depends on the previous number, okay, plus some increment, constant increment. Okay, it doesn't change with time. It is the same number that is constantly added to go in further and further, the entire sequence. This is what we are studying in today's class. Okay, and arithmetic progression, chapter number 5. Okay, my name is Joel. That's my Instagram ID. If you have any doubts with regards to this lesson that you feel like I did not understand and whom should I ask, you can just message me. I'll be able to help. There's also an YouTube channel. You can go and check any content of class 10 which you're not able to solve. There you can get a help. Okay, so without wasting more time, let's start in understanding arithmetic progression. The chapter is 4 marks for your board exams. There will be 1 mark MCQ and 3 marks word problem. So let us first try and solve 1 mark question, which are very simple, provided you understand a little bit of basics. Alright, over here I have cards placed with me and I don't know how many they are. So all I can say is I have many cards, or I might say in mathematical terms that I have n number of cards. Okay, so remember this. Now what I'll do, I'll just push all those cards in its place. Okay, now I can easily count the number of cards. So my n that I was saying, that n has turned out to be 8. So which means I had n number of cards with me and now I have counted how many they are. So I have 8 cards in total. Alright, so this is a very important point that you have to remember. So in an arithmetic progression, I can have many cards or many numbers like this. Okay, if I don't know how many numbers, then I would say n number. If I know, then I would say 8 terms. Okay, hope this thing is clear. Now, since all those cards are faced down, now what I'm going to do is turn the first card and see what is written behind it. Okay, so let's turn the card. So when I turn the first card, okay, it has A written on it. Okay, now always remember that the first number that is there in an arithmetic progression will be called as the first term, or and with the initial A. Okay, now let me turn the second card. Let's see what is there. That will be A2. Now in this case I've just given these letters. Okay, you can have numbers behind it also. So A2 only tells you that I have that 2 number in the subscript, tells you that it is the second card that I have turned. A2, or rather A, tells you the number behind it. Okay, so once the cards are turned, I don't know which card I have turned, right? So that subscript tells you which card you have turned. What if I turn the 7th card? It will be A7. What if I turn the 4th one? Then it will be A4. Can you think of what would be 8? Then it would be, so that means I have turned in all those cards that were placed, I have turned the 8th card, and what should be behind it? A8. So I hope you are able to understand till now what's going on. Let us come back to that same example that we started with. 25, 30, 35 and then 3 blanks for it. Okay. how long is my arithmetic progression, or rather how many terms are there in this entire arithmetic progression? There are in total 6 terms. So, I can think of it as 6 cards that are placed, and first 3 are turned. Okay. So, my first card that I turn, I got the number 25, which is nothing but also called as the first term with initial A. Okay. So, I can say A is equal to 25. What would be A2? It would be 30. What would be A3? It would be 35. What would be A4? Now, I have not turned that card, right? So, I do not know what exactly it is, but you were already able to tell me what would be the answer, right? So, you did a little bit, or rather your mind did a little bit of calculation, and you were easily able to tell. So, there is a simple basic formula which you can use to find out the numbers, okay, whatever in the arithmetic progression, and that is, we'll come back to the formula. So, first term is what we studied, common difference. The word common tells you that, you know, some probably when you go for a party or somewhere you go, and then you're wearing the clothes and same kind of a dress or same kind of a shirt someone else is wearing it, 2-3 people are wearing it. So, what would you say? The dress are common, everyone is wearing it, right? Common. So, the common difference over here in arithmetic progression only means that the next number minus the previous number. So, in this case it is 30 minus 25. Whatever answer that I get will be called as common difference. So, 30 minus 25, okay, the next number minus the previous one. Okay. So, 30 minus 25 will give me 5. Even if I try to do it for the next number. So, 35 minus 30, I will again get the answer to be 5. 5 is a common number, right. So, that is why it is called as common difference. Difference because I have taken 2 numbers and subtracted them. So, common difference usually denoted by letter D. So, first term denoted by letter A, common difference denoted by letter D, and you already know how to find that common difference now. Number of terms, if I do not know, I will say n terms. In this example of cards that are placed, I know how many cards are there, right. So, in this case my n or number of terms is nothing but 8. The example below that with those numbers, what is the number of, how many number of terms? 6. So, the number of cards that you are placing is the number of terms. I hope you are able to, you know, grasp in whatever, keep that vessel open. Okay. Value of a term, or rather an, is nothing but once you turn the card, whatever answer is there behind that card will be my an. Now, the reason I have written n over there, or rather an is given, is only because I am trying to open the nth card. So, I do not know what is the number, right. So, I have given that letter n number of cards, right. So, that is why it is an. But if I would open the 7th card, that would be the number behind it would be A7, the value of that term after you have done whatever is there underneath. And if you have understood all these things, then this formula will become very simple. An is equal to A plus n minus 1 d. If you are taking a book and viewing it right now, you can immediately write this formula down. It's there on your textbook, not something that I've generated from myself, but you can learn this formula. It's very simple. An is equal to A plus n minus 1 d. Let us break down that entire formula now. An means I am in that entire arithmetic progression, I am going to, turn one card, which is I don't know which one, right? So if I want to find out what is the answer, and by the way, your mind actually did all this calculation without even you realizing, and that's the reason you were able to easily tell me that the answer is 40 and 45 and 50 in the example earlier. Okay, so it's nothing difficult as such. So only thing, it was easy because it was a small arithmetic progression. What if it is a progression of 99 terms, and I ask you what is the answer of the 98th card that you are going to turn? It's going to become a little difficult, right? That's the reason, the formula. So AN, that means if I want to find out the answer to an arithmetic progression which has 99 terms or 100 terms, and I want to find out the 99th card that I want to turn. So what is the number behind it? Will be A99 is equal to that entire sequence, the first term that is there, I need to know that. So 99 minus 1 will become 98 multiplied by whatever was the common difference. Don't worry if you have not understood whatever I have said right now, we will solve a problem to understand it better. But remember the formula. AN is equal to A plus N minus 1 D. Is it done? Clear? Clear in your mind, right? Let's go ahead. These are the kind of fill in the blanks that you will probably get for your exam. The 10th term of an arithmetic progression, 4, 7, 10, dot 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 is dash. Now that dot 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 is nothing but it is telling you that the sequence continues, and we don't know how long is the sequence. Okay, so it might go on and on and on and on. That's the reason those dots. Okay, now but the sequence starts, the first number that is turned is 4, second number that is turned is 7, third number that is turned is 10. You know this much, so I can think of it as I have a list of cards that are placed down, okay, and I need to unturn or turn the card which is the 10th one, and first 3 are already turned for you, and the numbers that you can see are 4, 7 and 10. So what do you have to do? Simple, put that formula, okay, just for your imagination. Your 10 cards are here. There might be more cards, okay, so, but you are bothered about only the first 10. So first 3 cards turned, I got number 4, number 7 and number 10. The last card, which is a dash that you can see, is what I need to find out. So I will, first term is 4, common difference. How do you find out the common difference? Next number minus the previous number. So 7 minus 4 will give me 3, or 10 minus 7 is also going to give me 3. So you can, once you are told that it is in arithmetic progression, you don't have to worry about whether those numbers will be same or no. You can just check for one and it's done. But if you are told to check whether the sequence given is in arithmetic progression or not, then you need to check for the second number minus the first one, whatever answer, third number minus the second one, whatever is the answer. If all those answers are equal, then you can say that it is in arithmetic progression. Here in the question, you are already told that it is in arithmetic progression, so you don't have to worry. So common difference would be 7 minus 4 will become 3. Number of terms. How many number of terms are there? I'm concerned only about 10, right? So n for me is 10. Which number are you finding that will be your n? So I'm finding the 10th term. I'm turning the 10th card. That's the reason my n is 10. The sequence might continue. I'm not bothered. I'm just bothered about the card that I'm turning, 10th card. So 10. Okay. Value of that is what we are supposed to find out. So that's the question mark. Let's try the formula. AN is equal to A plus N minus 1 D. I already have the numbers. A is 4 plus 10 minus 1 will become 9 multiplied by common difference is 3. So let's write this thing down. Okay. So 4, which is from here, n is 10 minus 1, this is already there in the formula, multiplied by the common difference 3. So when I do all this calculation, what will I get? Is equal to 4 plus 10 minus 1 will become 9 multiplied by 3. Solve the bracket first and then do all whatever you want to calculate. So 9 multiplied by 3 will become 27 plus the 4 which is already there, add it and you get answer as 31. Which means in this arithmetic progression, if I was to turn the 10th card, if the numbers kept on increasing by 3, then the 10th card should have number 31. I hope this example is very clear. Simple problem. Let's try and find out another one. The common difference of arithmetic progression minus 3, minus 5, minus 7, dot, 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 dot is dash. So, it's an arithmetic progression. Okay, we know it. How do we find out common difference? We take the next number minus the previous number. So, I can take minus 7, minus 5 or minus 5, minus 3, whatever you want to. So, common difference is equal to next number minus the previous number. So, minus 5, minus 3, and there is already a minus sign in the formula, right. So, I will put that minus sign. Now, what is happening? See, there is one minus sign and there is minus sign for the number as well. I can't, that is mathematically incorrect to write two signs close to each other. So, what I will do? Put a bracket, and please avoid doing such mistakes because it shows, that you don't understand math really well, because when you put two signs together without a bracket, that's a very confusing, they look like two dash that you have put. So, put a bracket, simple. Now, minus and the minus sign which is there inside the bracket, you open it up and you will get minus 5 plus 3. Okay, do the math, minus and plus, minus 5 minus 3 will give you 2, sign of the greater number will give minus 2. So, that is the answer. So, the common difference of the arithmetic progression minus 3, minus 5, minus 7 is minus 2. The 8th term of an arithmetic progression, whose first term is 10 and common difference is minus 5, is dash. Again, I am turning the 8th card. Okay, so I have cards placed down, and there might be some more cards also, but I am bothered only about the first 8. I need to find out the 8th card number, okay, whose first term is 10. So, let us, okay, this is the one which I am finding out for. First term is 10, that is the first card, and you are not told about the second card and the third card, but you are told what is the common difference. So, so first term 10, common difference minus 5, number of terms, how many? 8, because the 8th one that I am going to turn, and value of an is something that I need to find out, right. So, what is the formula? An is equal to a plus n minus 1 d. What is the value of a? A is 10 plus 8th one, right. So, 8 minus 1 multiplied by the common difference, which is minus 5. Solve the bracket first. Okay. So, this would become is equal to 10 will be as it is plus 8 minus 1 will become 7. 7 multiplied by 5 will become 35 with a negative sign. So, it is negative 35. So, this is what you will get. Now, again plus sign and a minus sign. I do not want that, right. So, let us put a bracket. So, when you open that bracket, plus and minus will become minus. So, minus 35 plus 10, subtract them together, what I will get? 25, sign of the greater number, negative 25. That is the answer. I hope you are able to understand. These are the kind of 1 mark questions that you can get for your exam, and that's very simple provided you understand what is the first term, what is the common difference, number of terms and value of an. That simple. And if you have understood all this thoroughly, you can solve these problems. Okay, you can write them down. The common difference of arithmetic progression -1, -6, -11 is dash. Simple. Write the same formula, an is equal to a plus n minus 1d, calculate, solve it. Then the 19th term of arithmetic progression is given to you is dash. So cards are placed down, I am turning the 19th card. The common difference of an arithmetic progression, again 8, 27, 36 is dash. So what is the common difference? How is the increment happening? How do we calculate? Next number minus the previous number, and done. The fourth term of an arithmetic progression, whose first term is 21, common difference is -3. Again, put the same formula, easily you can calculate it. In an arithmetic progression, first term is 8, common difference is 4. Then the 9th term is dash. Simple again, you are turning the 9th card. 6th question, you are turning the 15th card in that entire list. The 20th term of an arithmetic progression is again 20th card, and wait a second, the sum of 8 natural numbers, sum starting from 3. What kind of question is this? And this is not what we have studied by now. Okay, so we are going to solve it now. The sum of 8 natural numbers starting from 3 is dash. Natural numbers, first of all you should know what are natural numbers, starting from 1 to infinity. Okay, starting from 1 to infinity they go on, right? The sum, what is the meaning of the word sum? Which means solve ko taite anuwa add. Okay, so sum means adding numbers, right? We are adding 8 natural numbers. Starting from where? Are we starting from 1? No, we are starting from 3. So these numbers. Okay, so 8 natural numbers are added together, whatever the answer is. Now, since you can see all these numbers, it's very simple, right? I take a calculator, calculate 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus 9 plus 10, and I'm done with the answer. But what if I tell you, you have to calculate sum of first 20, 30, 45? It becomes difficult, right? So there's a simple formula that you can use, and that is Sn. Remember the initials, okay? The letter S tells you that it is sum, okay? N tells you the number of terms, right? So sum of n terms. So in this case, it would be S8. So sum of 8 terms is equal to n upon 2 bracket, okay, A plus L. Now in this entire formula, the only 2 things which you are studying, which are new, are Sn, which is nothing but sum, and L, which is the last term. That means if I have to use this formula, then I need to know what is that in that entire sequence, what is my last number. So here my sequence starts with 3 in this case and ends with 10, right? So I know what is the 10th, or rather the last number that is there. So it is a sequence of 8 terms. I know what is the answer, the last one. So that is the reason I can use L. L means last term, the answer to that. Okay, so this would become S8 is equal to N is 8. So 8 upon 2. First term is nothing but 3 plus last number is 10. Solve the bracket first. I'm continuously telling you all this because I want you to solve them this way, because if you just start randomly solving anything, there will be a complete wrong problem answers. So 3 plus 10 will become 13, 8 upon 2 will become 4. So 4 multiplied by 13, and the answer is 52. That's it. So if you were to calculate actually 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus 9 plus 10, the answer that you would get is 52. One simple formula and you can get the answer. So till now, whatever we have studied, we learnt two main formulas of arithmetic progression. We understood what is the meaning of arithmetic progression, and we learnt different terms, that is the first term, common difference, number of terms, the value of that term, that is an. We learned what is Sn, we learned what is L, and I hope that whatever is done in this entire class is completely clear and you have been able to grasp whatever was taught. If you haven't, then please watch the video again and learn it. Thank you very much.